Hi, so today we're going to be learning topic 1-2. Our goals are to classify real numbers and use properties of real numbers to evaluate expression. So all your real numbers can be classified into two main groups. You have your rationals and your irrationals. So basically any type of number in this chart we're going to go over is considered real. Irrational numbers are the ones that do not terminate or end, or the ones that do not repeat. So square root of 3 is considered irrational because if you take the square root of 3 and turn it into a decimal, you get about 1.73 and it keeps going forever. So since it's not going to terminate and it doesn't have a specific pattern that it repeats in, it's considered irrational. Pi is about 3.14159 and it keeps going forever and ever. So since it doesn't terminate, it's irrational. Now here, this next decimal looks like it repeats, but it actually doesn't, because you'll notice the pattern of zeros is not the same. So it would have to be 1001 every time. Since they're adding zeros, it's not repeating. So that's what makes it irrational. Again, if something's irrational, it's considered real. Your rational numbers are anything that can be represented as fractions or decimals that terminate or repeat. So 5/3, that's a fraction, that's a rational. 0.63 is a decimal that terminates, so it's considered rational. It can also be written as a fraction, like 63 over 100. 0.012 is a repeating decimal. Since it's repeating because of that line on top, that means that it's rational. It can also be written as a fraction, or if you want to continue it as a decimal, you would just repeat that 12 forever and ever. I put -10 and 6 here because even though they look like like integers or whole numbers, they can also be written as fractions or decimals. -10 can be written -10 over 1, so it's considered rational as well. And 6 can also be written as 6 over 1 or 6.0. So it's also considered a decimal that terminates. Therefore, it's rational. And remember, anything that's rational is real. Integers are your numbers, or your whole numbers that also include negatives. So -2, -1, 0, and so on. Those are your integers. I put square root of 9 here because some students will think it's irrational. But if you take the square root of 9, that actually comes out to 3. So it's really an integer and a whole number. Your whole numbers start with 0, and then you go to 1, 2, 3, 4, 5. I put square root of 36 here because it might look irrational. But if you take the square root of 36, it actually equals 6, making it a whole number. You'll notice all your whole numbers are also integers, and they're also rational and real. Your natural numbers start with 1, and then it goes to 2, 3, 4. So notice I put square root of 4 here because it's actually equal to 2. So square root of 4 is also considered natural since it becomes a whole number. So basically, the way you would read this chart is if you have a natural number, it's also whole, integer, rational, and real. If you have like an integer, then it's also rational and real. So integers can be rational and real. You would read it going up. Let's go ahead and do some practice problems of classifying our numbers. So here we're going to classify all the number sets that these following numbers belong to, starting with -23. So -23, since it has a negative, it cannot be a natural number, a whole number, so we would have to start by saying that it's an integer. And since it's an integer, it's also rational. And that's because you can write it as a fraction, like -23 over 1. And it's also real. Remember, all your numbers are real. Now, just because it's negative doesn't make it an integer. If it were a decimal, like -23.5, then it would only be rational and real. Square root of 50 looks irrational. Let's check if it comes out to a whole number. If you were to do the square root of 50 on a calculator, it would come out to 7.07, and then it would keep going. Therefore, it is irrational because it does not terminate or repeat. And if it's irrational, it's also real. Again, all your numbers here are real numbers. -4/9 because it's written as a fraction and can't be simplified to a whole number or anything like that. It's considered rational and also real. So again, just because it has a negative doesn't mean it's an integer. Here, it's rational because it's a fraction. For it to be an integer, it would have had to have been a negative whole number. And then square root of 81 looks irrational, but if you work that out on a calculator, it's equal to exactly 9. Since it's equal to exactly 9, the best group for that to go in would be natural. And since it's a natural number, it's also whole. It's also an integer. And it's also real. So here we listed all the number sets to which these belonged.